So our title is Single Bus Organization. We are from D1 batch. So starting of the topic. So first point is function and purpose with the system, which includes the data transfer. The primary function of the bus is in the computer system is data transfer. It serves as main communication link between data transmission, key key components, including CPU, memory, various input outputs devices. The data may include instructions that CPU must execute, information that needs to be processed, or the data that program requires two functions. Second is addressing. Addressing is another crucial function of the bus, which is responsible for the transmission of address information within the system. This function allows the CPU and other components to specify the exact location in memory within input-output devices, where data should be read from or returned to. Third is control signal. The bus transmissions controls the signal that coordinates and manage the flow of data across the system. These signals includes read and write commands as well as the control information necessary for synchronizing the actions of various components. Control signals are crucial for maintaining and organizing flow of operation, allowing CPU to control devices to either send or receive data. The coordinates ensures the different components of operations in scan occurs in orderly manner. Fourth is power distribution. In certain computer architectures, the bus is also used to distribute the power to various components. This function enables the bus to supply the electrical power to similar devices or components directly or indirectly in the system. Power distribution through the bus simplifies the design and reduces the complexity of the system writing, allowing components to draw the necessary power directly from bus to operate efficiently. Each of these functions, data transfer, addressing, control signal, and transmission, and power distribution, contributes to the overall efficiency, organization, and functionality of computer system, enabling smooth operation across the all the other parts. Now I hand over to my teammate. Thank you.
So after that, there are the components of connected by a single bus. So there are various components which are connected by the single bus. So first is processor, which is the CPU. So what it does is it executes the instructions and the process data which is to be executed. Also, it is also known as the brain of the computer. After that, memory. So memory temporarily stores the data for the CPU. It is connected to CPU through the bus for the more efficiency. After that, input output devices. So they are basically the interface between the external devices like keyboard, mouse, etc. After that, communication pathways. So there are various shared routes between the different components of our computer systems, which are used to transfer the many things. So basically the memory, data or address part which we want to transfer from one part to the another part. So they are the components which are the connected by a single bus. Next slide. So there are various types of buses. Few of them are listed here. So first is data bus. So data bus is used to transfer data between CPU memory and input output devices. As you can see in the chart also, data bus is used to transfer the data from CPU to the input output devices. After that, there is address bus. Address bus carries the address and locate in the memory where it is need to be stored. After that, there is the control bus. So control bus sends all the controls to manage the all the executions, as well as it manages the time between the CPU and memory input output devices. So after that, power bus is there. So power bus supplies electrical power to the components so that they works without any issue. They work reliably so that we can perform our task more efficiently. As so here in the chart also you can see that it explains very nicely that CPU transfer is also connected to data bus, memory is also connected to the data, and input output, all are these connected to the each other. So they are the very important part of our computer system. Thank you so much. Now I would like to hand over to the Shubhdas to please continue.
Thank you, Lucky. Yeah. So my slide is about data transfer in single bus system. So in this slide, we will explore how data is transferred in single bus system. A bus system is a crucial part of a computer architecture. It acting as a communicating bridge between CPU memory and peripheral devices that is similar to that. What is a single bus system? A single bus system uses a single communication pathway that is shared among all of its components. Imagine it as a highway where all vehicles share the same road to reach their destinations. Moving forward, the question is how data is transferred or how does data transfer happen? So there are three main stages as it is shown in the diagram also. The first of these is when multiple devices want to use the bus simultaneously, arbitration decides which bus device gets control. The first from this is bus cycle. Uh, first there, first there the address phase where the sender specifies the destination address. Then comes the data phase where the data actually is transferred. The second one from this is control signal. These signals like read or write guide the operation to ensure data flow correctly. So what are the advantage? So advantage of a single bus system is using a single bus system is simple and cost effective. It reduces the complexity of having multiple communication paths. Challenges. So however it has limitation, since all devices share the same bus, it can become a bottleneck or it can become a very hard. Imagine a highway jam where everyone is waiting their turn. That's similar to how devices queue up to use the bus. The next one is transition. Now that we have seen how data flows in a single bus system, look at how communication itself can vary in the next slide. So next slide is about types of communication. Communication is computer systems can happen in two ways. Communication system can happen in two ways, which primary ways are synchronous and asynchronous. Both have unique characteristics and are used in different scenarios. Let's talk about this more. Synchronous communication. First, let's talk about synchronous communication. In this type, all components involved in the data transfer are synchronized by a shared clock signal. For example, for example, imagine a relay race where runners pass the baton at the next person, intervals marked by a timer. Similarly, in synchronous communication, data is transferred at predictable intervals. So, what are the key features? The key features is that the timing is predictable because it is shared clock signal and it's faster and efficient also, especially for short distance where delays aren't an issue. For example, one classic example is the communication between CPU and RAM. Since they are closely connected, synchronous communication ensures fast and reliable data exchange. The moving on to the second one type of communication that is asynchronous. So in this method, there's no shared clock signal concept. Instead, their devices rely on start and stop signals to manage data transfer. You can take it like sending letters through mail. There's no strict timing. You just send when you are ready and the recipient processes it when it arrives. So what are the key features? The key features of synchronous communication that is that it is flexible and doesn't depend on strict timing. It's suitable for long distances and communication or device that operate at different speeds. For example, a common example is universal asynchronous receiver transmitter, which is used in serial communication between computers and embedded devices. Comparison to Summarize, synchronous communication is about speed and predictable, whilst asynchronous communication provides flexibility and adaptability. So, what do we conclude from this slide? Understanding these communication types helps us design efficient system tailored to specific requirements. Both approaches, both approaches play a critical role in ensuring smooth data transfer in modern computing. So, by closing this, from my side and from our team, uh, on data transfer in a single bus system and the two mesh types of communication, I would like to end my from my side. Thank you. So, our topic from the single bus, our topic from the single bus system is over. Thank you.